Okey.
Terasa semangat untuk Malaysia, agensi di bawah Kementerian Belia dan Sukan. Berisi Kepala Laporan Aduan Rakyat bersama wartawan Khairul Rizwan Azizan.
Malam kami memaparkan masalah ketiadaan bekalan elektrik di Politeknik Cameron Island. Ia membataskan aktiviti penduduk orang asli, terutamanya pada waktu malam. Anak-anak kerja menghadapi masalah berulang kaji pelajaran dan terpaksa bergantung kepada cahaya daripada pelita dan unggun api. Prihatin dengan nasib penduduk orang asli di kampung ini, pihak Malaysia tampil membantu pemasangan teknologi tenaga solar. Lain kampung Hitung, dua lagi kampung yang perlu menerima manfaat daripada projek ini, kampung Kemian dan kampung Jernang. Secara keseluruhannya, projek berkenaan memberi manfaat kepada hampir 300 jiwa. Setiap keluarga dibekaskan dengan sistem asas seperti panel solar, selain tempat gigi rambut dan pengecat PSP. Di sini, tak seperti bekalan itu, kerana di pos itu makin ini pokok kampung. Lagi dua kampung itu itulah jadi tiga lagi jenis buatan polis dapat jauh ke dalam dan dia lebih kurang menjadikan percikapan okey.
Dah. Dah. Nah, kalau awak akan pandang teks, mata akan macam tunduk sangat tak? Mata kamera. Okey. Ya. Minimas tu bisa buat. Cuba sikit. Kita ni merah cukup. Lepas akak panggil sikit. Terus balik belakang. Dah. Mau tanya dia nanti. Tak view kan? Okey, ni saya download dulu. Depan siapa? Dia asal siapa yang depan? Depan yang masuk.
Kami adalah Malaysia.
Steven. Kami nak pandang siapa? Pandang siapa?
Lagi dulu. Switch yang lagi.
Dah penuh dah. Macam mana?
Di Indonesia tu yang tak satu Muslim pasal apa itu
Macam kita lah. Dua-duanya ada orang tak? Ada orang tak? Siapa? Lagi.
Nah.
Tak baca ni. Sampai ni. Skrip ni. Untuk je.
Itu boleh tu.
Ni 40 minit. Boleh makan sekali. Kita lebih duduk kat sini. Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Ladies and gentlemen, our program is about to commence in a few moments. Before we begin, we would like to remind you to mute your microphone, keep the audio channel free of clutter and available to the speaker. Use the raise hand function or chat when you want to speak. All attendees are also reminded not to leave the meeting until the program is finished. And all attendees are requested to use the visual background previously shared. Your cooperation is highly appreciated. Thank you. Bismillahirrahmanirrahim. It's an honor for me, Norhasnina binti Asri, as your moderator to host this special program. To all our honorable guests, speakers and students from Politeknik Sultan Azlan Shah, Malaysia and Politeknik Negeri Bandung, Indonesia. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. First of all, I would like to welcome all of you to Harnessing the Power of Nature Go Solar Education Program, a collaboration between Politeknik Sultan Azlan Shah, Malaysia and Politeknik Negeri Bandung, Indonesia. For everyone's information, program today is participated by students from Politeknik Sultan Azlan Shah, Malaysia and Politeknik Negeri Bandung, Indonesia. Respective guests, our program today will begin with the doa recital. In order for a peaceful and smooth program this morning, I would like to hereby invite Mr. Muhammad Rosdan Muhammad from Politeknik Sultan Azlan Shah to lead us for a word of prayer. I would hereby like to call upon Mr. Muhammad Rosdan Muhammad.
Conduct in our life. We ask you for knowledge which is beneficial and sustenance, which is good and deeds which are acceptable. Ya Allah, help us to remember you, to thank you, and to worship you in the best of manners. Forgive us, have mercy upon us, guide us, give us health, and grant us sustenance. Allahumma ya hafizul ya raqib. Ya Allah, you are the most forgiving and one who loves forgiving. Therefore, forgive us. Rabbana atina fid dunya hasanah wa fil akhirati hasanatan wa qina azaban nar. Allahumma inna a'udzu bika minal barasi wal jununi wal juzami wa min sayil asqam. وصلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم والحمد لله رب العالمين.
Thank you very much, Mr. Rosdan Muhammad, for leading us in a word of prayer. Ladies and gentlemen, without a further ado, I would like to invite the first speaker from Electrical Engineering Department, Politeknik Sultan Azlan Shah, Malaysia. Ms. Nurul Azimah Ahmad Azraai will share on introduction of project-based learning. Respectfully welcome Ms. Nurul Azimah. Share lah. Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning again to everyone. My name is Nurul Azimah binti Ahmad Azraai, one of the lecturer in Electrical Engineering Department of Politeknik Sultan Azlan Shah, Perak, Malaysia. I'm very happy to be here with everyone today. Okay, so I will talk on introduction to project-based learning. So let's watch a video first.
Sometimes paused as much as you could, trying to pass a test at the end. Is that good enough? These days, school can be interesting and effective, focusing students on more knowledge. This is project-based learning, explaining. First of all, the name of the world of projects. It's a start assignment, improvement, community learning, and to actively solve problems. But unfortunately, schoolwork looks more like this or this. This is project-based learning. She was recently presented with a challenge. Super says, so, it was up to her to find the only way she could tackle in the future. Let's go for a budget and a few requirements. It's up to her to come up with a solution. She organized and managed a team, researched the options, and the materials summarizing the issues. This team asked for feedback and presented their findings to the boss. Like a rock star for the lot about green products. If you look closely, their success involved critical thinking, collaboration, and communication. Things that aren't often taught in traditional classrooms. The world needs more cleaners. So how do we get them? The answer is project-based learning, PBL. By focusing students on a project, teachers put them on a path that deepens their knowledge and build skills they'll need in the future. Here's what I mean. Mr. Simmons has always been a good science teacher, and the students do well on Friday's tests. Unfortunately, what they learned was gone by Saturday morning. That wasn't good enough for him. Soon he learned about project-based learning, decided to give it a shot. Mr. Simmons got the idea for his first project, microorganisms, when nearly half of his students were suddenly absent with the flu. He asked his students why they thought so many of their classmates got sick at the same time. That lively discussion posed a lot of good questions, and a list of things the kids wanted to know. Mr. Simmons then announced the project was to help elementary school kids understand how can we not get sick. After dividing the class into teams, he got them started on the project. It was up to the students to ask questions, research, collaborate, and each other feedback and figure out the best ways to make their points clear to children. One team chose to make an education video on the connection between hand washing and avoiding the flu. Another chose to create posters to show how viruses spread. The project team showed off their final work to an enthusiastic audience of parents and their children at a nearby elementary school. Sitting in the front row was our good friend and local rock star Claire, who saw a bit of herself in the students. It was clear that the project was a success for the students, audience, and Mr. Simmons. The students practiced critical thinking, collaboration, and communication. The project wasn't about memorization, but learning in depth about viruses and how to prevent spreading disease, a lesson they will never forget. At the end of the presentation, Claire introduced herself to the students, told them that they were rock stars and that the world needs more people who can think like them. To learn more about project-based learning, go to BIE.org.
Okay, from that video, we can conclude that for project-based learning, instead of lecturer giving all the information to the students also need to work, to investigate, to do some research and to collaborate with each other to come out with their project. For engineering students specifically, you will have assignment project. For example, in PSAS, in electrical engineering department, you start project with your semester 2. In programming, you have a project assessment. You also have final year project during your final semester, which is semester 4 and semester 5. So all these elements, to complete the task, you need to collaborate, to gain your own experience, to find your own knowledge and term to come out with the project. So in project-based learning, we have 7 essential elements. They are challenging the problem. This is normally the problem statement. From your observation of your surrounding, you come out, you observe what are the problems. You come out with a solution, you come up with suggestion to solve the problems. The project is framed by a meaningful problem to be solved, a question to answer at the appropriate level of challenge. So for example, okay, any final year student here, semester 4, any semester 4 or all semester 5. So what is your project title, final year project?
Protection women safety using ESP.
So what is the problem you're trying to solve?
Trying to protect women using ESP. We design the first pattern.
So protecting women. So the problem, there are so many harmful evidence we can watch in the television, from the paper. There are so many events that harm the women. So very good, you come out a solution to protect the woman. Anyone else from the gentleman here?
System.
Energy saving system. What are you trying to save?
Electricity.
Using IoT. How you save the energy using IoT?
I use sensor to detect people from when the sensor detect people electricity with.
Very good. So you, from your observation, you can come out a lot of problem and you try to solve the problem. That is challenging the problem. Okay, for sustained inquiry, students engage in rigorous extended process of posing question, finding resources. So from your question, so you know there is always excess electricity when students come in and out of the classroom. Sometimes they forgot to turn off the light, the fan. So there is a waste. So you come up with a solution so that the lighting and fan can turn off automatically using the sensors. You can also use other electrical source such as solar system if you have the capability to do that. So you can always question, do research to solve the problem. Okay, what is authenticity? Authenticity is the project involve real world context. So it's not a model. For example, when you do a project for a parking lot system, you do the project at the parking lot, not do a small model. That is not authenticity. So for example, if you're saying you're using solar panel to produce electricity, so you use actually solar panel that can light a lamp, that can switch on a fan. So that is authenticity. You use the project for the actual life situation, not just some small model. Okay, and then student voice and choice. What is student voice and choice? The lecturer, your supervisor actually listen to your opinion. I want to do this, I want to use this, and then discuss. For example, if you choose an Arduino, there are so many types of Arduino. We have Arduino Uno, we have ESP, we have Nano, we have Micro. So you as the student, you as the project main holder, you choose which one you want to use. You can choose what sensor you want to use, what type of output you want to use. That is your own choice, your own voice. Reflection. What is the reflection? Based on your research and finding, you can conclude which microcontroller you want to use the best for you. For example, if you're using IoT, it is more advantage for you to use the ASP instead of Arduino Uno, because for Arduino Uno you have to add on controller for the IoT part. But if you're using ESP, it can cover both the Arduino and the IoT part, and it is much cheaper for you. So from that, you can reflect from all the research, you can reflect and make conclusion. And at the end of the day, you present all your funding to your lecturers. So, and your lecturers will give comment to you. This is the critique, and you can revise what are your findings to change something for the better. And finally, you present your product. So for final year project student, at the end of the semester, probably week 12 here in electrical engineering in PSAS, you will present your product to your audience. We sometimes invite industrial partners to watch your demonstration of the product. And if your product is actually good, your supervisor willing to put on some money to advertise your product, to join any other competition outside to gain some recognition for your product. Okay, so for these 2 days, this is our main problem. Okay, this is the route from electrical engineering department to the CAFE. There is only one light source along the route from the electrical engineering department to the CAFE. During daytime it is not problem, but at night time, sometimes it is not good enough lighting for the user. So we need to brainstorm idea. What we can do to solve this problem? Any suggestion? What can we do to increase the lighting here? Instead of only one lighting, using electricity to make the route more brighter. Any suggestion? Use solar panel. Solar panel is for the source, electricity. That is one option. You can use solar panel. So this is the power source. But it still has one lighting. Add on what? Add on? Add on the light. The number of light. Anything else? Anyone else? Add on the number of light using solar panel for the power source. Can we add any IoT element to the system? For what? For what purpose is the IoT element? Sensors. You want to add sensors for? Tracking what? Tracking. Okay, so you add sensors. Oops, sorry. To detect the user. So when someone came to the route, it detect the user, turn on the extra lighting. Okay, and then the lighting use power source from solar panel. Instead of using solar panel, can we use the existing power source of the building? Do you need to do anything to just add the load? Or you can just add the load, or you need to do something to add the load? Do you need to contact the electricity provider? For example, you need to change the MCB because you're adding the load. Do you need to do anything to that?
The MPS first, and let's say the MPS is not enough current for them, like then electricity mains, change the MCB, or maybe other than that we must add another, maybe that light will be 5 amperes, 2 amperes, we can add another 2 amperes. We can add.
Very good. So you check the current provider. So if it's enough, you can use the existing power. When you use the existing power, you actually add the load to the company. Because you're using the light, of course, there is some bills to pay. Okay, so, and then you need to calculate the load. Maybe some wiring need to be changed. Okay. When you're using the sensor, what is the advantages of using the sensor instead of just using switch on and switch off normal switches? Save what? Electricity. Are you sure you'll be save electricity?
At the same time, like the meter going on and off, right? So when the sensor is there, they can sense and then you can on and off automatically.
Okay, you save time. Of course, you save some electricity, but the amount is too little actually, because lighting doesn't use not many amp, small amp. Okay, so there are many type of lighting. Pandafloor, LED, T8, T5. Can you choose any type of lighting that can give you more saving? Instead, you have Pandafloor, you have LED, you have bright lamp. Comparing LED to Pandafloor, which one is more cost saving? Are you sure? Why? LED use AC or DC supply? LED use AC or DC supply? Okay, I'm asking if you're going to do this project. You're going to use AC or DC supply? DC. Why are you using DC, not AC? This is brainstorming. When you have one question, you came up with the answer and will produce another question. You gain the answer, it will produce another question until you came out with the project. Okay, this is where your supervisor take a part, questioning your answers, guiding you to the right track. Okay, for example, you're using LED, you say you're going to use DC supply. If you're going to use DC supply, for sure you have to, if you're using DC supply and using the existing power source from the TNB, the power source is AC, correct? Alternate current. So if you're using alternate current and your light is DC, you have to use something to convert AC to DC. You have to use some sort of inverter to convert the AC supply to DC supply. So that is a cost. Okay, for example, using solar panel. From solar panel, we have solar panel controller. The controller produce DC. The controller is connected to battery. Battery is AC or DC? DC. So from that battery, you can directly go to your LED. But you have to consider the cost for the controller, the cost for the battery. So all these costs, all this comparison need to be taken into consideration during designing your project. Whatever your decision ultimately will affect your project costs. How much money you're willing to spend for the project. So you need to do some research. So this is the sustained inquiry part. You do some research, you need to do a lot of reading to come out with what your own solution for your project. And you will present your finding. This is weekly discussion with supervisor. Present your finding. I'm going to use this sensor. I'm going to use this battery. What type of battery? The battery itself has its own rating. The cost is different. Everything is costly. So you have your own budget as a student. How much money are you willing to spend for your project? This will also affect your project cost. So you have to consider all this during your brainstorming idea. Of course, something will always come up later. So always have contingency plan. Okay, so PBLs helps improve student learning by increasing student engagement. Why is increasing student engagement? Because you always have to find information, discuss with your friends and supervisor about your finding. Is this correct? Is there any better way to do your project? Meeting state and common core standards. Because when you do your project, you need to consider every element in your project. Strengthen communication and collaboration skill. You have to communicate with your audience. If you want to sell your project to high institution, you need to talk to the head of department. Can I install my project here? If you want to use a product for entrepreneur, you need to communicate to the entrepreneur. Can I do my project? Can you use my project? Try my project. If it's good for you, can you buy my project? So you have to collaborate. Allow the student to use technology, 21st century skill. For example, the IoT part. 21st, that is one of the main element in Industrial Revolution 4.0. Making real world connection. When you have using authenticity in your project, you are using real world connection. Giving students control over his or her own learning. You decide your project. You decide your product. You decide what sensor you're going to use, what controller you're going to use. You have control for your project. Of course, your supervisor still has a say, because sometimes you will go to a different route, more difficult route. So your supervisor will still lead you to the correct path. So that's all from me. I hope you learned something from me. And if you have any questions?
No.
I know my students are very good. Always no questions. Anyone from Bandung have any questions? Boleh communicate ke dengan Bandung? Oh, you. Okay, that's all from me. Thank you very much. Assalamualaikum.
Thank you very much for an interesting sharing from Miss Nurul Azimah Ahmad Azraai. Ladies and gentlemen, the program will continue with the next speaker, Mrs. Hasnina Haji Abdul Rahman from Electrical Engineering Department, Politeknik Sultan Azlan Shah, Malaysia, with the topic of solar energy, the beginning. Without further ado, please welcome Mrs. Hasnina Haji Abdul Rahman.
Testing 1, 2, 3. Assalamualaikum warahmatullahi taala wabarakatuh, and a very good morning. How are you? Have you taken your breakfast? I also hope the audience out there also have taken your breakfast. So for today, I'm representing for solar energy, the beginning. I'm Hasnina binti Haji Abdul Rahman. And what I'm gonna say for today is yang shui burning mirrors. Anyone know what is yang shui burning mirrors? Have you watched Kung Fu movie? Okay, this is the ancient mirrors around 3,000 years ago. So this is the man who using the yang shui burning mirrors to focus the sun rays, okay, to what he is trying to do. Okay. Fire. For what? Why they need the fire? All right. In ancient China, a burning mirror was a very useful tool for cooking foods. Confucius writes that every son in a family will wear a burning yang shui mirrors to his belt as a dress for every day, so that later they can starting the fire for the family. So they were in a similar way by concentrating the power of the sun, but instead of using that power to make a fire, they cook the food directly. So these are the ancient China burning mirrors around 3,000 years ago. Nowadays, we can't see any Chinese wear these yang shui burning mirrors. Do you want to wear it? I bet no. So actually, solar energy has been used from 7th century. This one is an oven made out of clay in Morocco. They're using heat from the suns to cook the bread. Then the other side is the picture show in the year 1953, designed and made in India. This was featured in the Sun Living with Our Star exhibitions at London in the year of 2018. You can see they're using this to cook. But as you can see, there is the evolutions. Before this, at the ancient China, they are using burning mirrors to concentrate the rays to focus and light the fire. They could get from it. But in 1953, India already developed, they are only using the solar cooker and directly. So in solar, we have two, direct and indirectly. That is very basic that you must know about the solar energy. Okay, this is a picture of me. This is my first solar cooker. Instead of we learn the history, you should try for yourself. It's one of the survival skill. Let's say if you are in the middle of chaos, flooding, or you are, I don't know where you will be, and you lost, you don't have anything to cook. Maybe you don't know where to find the aluminum foil. But let's say if something happens and you trapped in your house, like around of your house surrounded by the flood, by the water, you cannot go out, you can find aluminum foil. I think most of the house you have the aluminum foil or something that can reflect it. You can using your manila card or your newspaper or anything to wrap the aluminum foil. Okay, why I show to you as my introductions, the story of energy, the beginning, because this is one of the survival skills. So you can do like a square and then you can make it like a flower. So the idea is to make sure that sun rays can concentrate in the middle of the center of the solar cooker. In the Western, they are using the Copenhagen cooker. And for me, it doesn't matter what kind of material, but why I show this picture of me, because this is the cheapest way. Because in the survival, you already watch MacGyver. Have you see the movie? MacGyver is a very old drama, but they use anything to survive surroundings. So you can use these materials in your house for survival and do your own solar cooker. The main idea from the ancient China 3,000 years ago is to concentrate the sun rays, focusing in the middle. Okay, so later I will show you how to know where the suns and what should you do. But as you can see, the other picture is I try to cook by using my selalu kita panggil ni kolej or anything that you can also use some stainless steel because it will more heat faster. So this is the world's largest solar furnace. In the 18th century, burning mirrors or lenses were used in chemistry experiments. They have advantages over burning charcoal, as the heat from the sun did not produce any pollutants which could contaminate the experiment. For example, Joseph Priestley used a burning mirror in his celebrated experiment in the year of 1774 when he discovered a new chemical element, oxygen, named by his rival Lavoisier. Today, the world's largest solar furnace, as you can see at Font Romeo Audelovia in southern France, is used as a research site for studying material at high temperature. This largest solar furnace was built in 1960s and used 9,600 mirrors to reflect the sun's ray onto a central target. Okay, in the middle is the central target, which just only a few seconds, the temperature can raise up to 3,500 degrees Celsius. Just a few seconds. Some said in the research, they said less than 5 seconds. So imagine less than 5 seconds using the solar furnace, it can melting any materials because the temperature is 3,500 degrees Celsius. What will happen to you if you jump into a boiling water of 100 degrees Celsius? Can you survive? No. So, throughout the history from the ancient China to the modern day France, people have used the sun rays to make fire, for cooking, and for weapon, and also do some experiment to melting any materials. So people around the world utilize the power until today. All right. Have you seen this picture? Okay, this picture is from 1646 from the Wellcome collections. This is the potential destructive power of burning mirror was recognized as far back as the ancient Greece. Okay, just now we go to the ancient China, now to the ancient Greece. Legend tells the exploits of Archimedes, who set fire to enemy Roman ships during the siege of his hometown Syracuse with the help of giant mirrors. So you can see the sun's reflecting to the ships. Although unlikely to be true, the idea is very fascinated science in 1600s who tried to relate and explain the phenomenon. When we see the picture, do you think this is possible? Anyone? Okay, the idea of using this technology as a weapon is explored in the James Bonds. Anyone? Have you watched Die Another Day film? So the plot revolves around Betty Gustave, who used a huge concave reflector in space to focus the rays of the sun onto Earth, wreaking destruction and causing the havoc. So I think I would like to show you the movie. Giant reflector at the space.
Being able to bring light and warmth into the darkest parts of the world. Imagine being able to grow crops the year round, bringing an end to hunger. Imagine a second sun, shining like a diamond in the sky. Gentlemen, I promised you a demonstration. Now you will see the true power of Icarus. Western spy runs but he cannot hide.
That's how the Archimedes, who set fire to enemy to the Roman ships. Okay, the James Bond prove it with the film, of course. So, but in this 1600th century, they are using the big mirror, giant mirror, to focus to the ships. And when we look at the films Die Another Day, it's a possible things to do. Even though you can use the magnifying glass by focusing into some paper or whatsoever that something is easy to burn, and you actually can set fire on yourself, but don't burn your house. This is only to show the power of the sun's ray. Okay, so from the beginning, I show you about the solar cooker, I show you about the how starting the fire and weapons. These are the basic benefits that people before the era of technology use the sun rays to utilize the power of suns. But today topic is the solar energy. So I bring you starting from the 7th century, the history of solar energy that I have already shown you before this. From the solar cooker, from the oven using the heat from the suns. All right. So actually we have active solar and passive solar. So when you see the oven from the Morocco, it's actually a passive solar because it receives heat from the suns to cook. But when you see the burning mirror, that is actually the active solar. Why? Because it's directly get from the sun. So solar, the Greeks and Romans used the burning mirror to light torches to religious purposes other than to as a weapons. So by the 6th century, sunroofs on houses become popular. Justinian Code initiated sunrise to ensure individual access to the sun. So you can see in my slides, in the year of 1767, this is the first solar collector cell. Was designed and constructed by the Swiss science. Okay, this is very hard for me. I tried several times. Horace Benedict de Saussure made the discovery when heat power mainly steam was tested. So he constructed an insulated box with an opening and 3 layers of glass. So these are the solar collector cell that Horace Benedict de Saussure have made it. This glass magnified the sun's heat to temperature in excess of 230 degrees Fahrenheit and was used in a variety of ways. In the year 1839, this is the first photovoltaic effects has been designed from the young French scientist. Okay, how old are you now? 20. I really hope you and also audience out there can do a science magic because the photovoltaic effect has been discovered by the French scientists who already at that moment is 19 years old. So young. So after exposing it to light, the energy increase. Wildo by Smith described the effect of lights on selenium. So these are the first photovoltaic effect in 1839 by the French scientists. In the year 1888, okay, why I show this picture? Because this picture shows French scientist, and this one shows Russian physicist called Alexander Stoletov, because he is the one who increased the efficiency of photovoltaic cells until present day, because this is the discovery that he made. It was discovered that ultraviolet rays can cause a spark to jump between 2 electrodes. This led to the creation to the solar heater until 1891. So these are the historians, scientists, physics that found the evolutions of solar cells and photovoltaics. Okay, why do we need solar energy? Why do we need solar energy? Not only in Malaysia, I think other country also have a rural area where you can, where the fossil fuels or anything that you can, the grid system distributions cannot reach the area. So the solutions to give the energy to the people in the rural area is by using the solar energy. So here is, you can see the clinic desa Postitam actually in the middle of hearts of Malaysia. It's located in Pahang. And I show you.
Assalamualaikum warahmatullahi wabarakatuh. Datuk, kita ada kat mana Datuk?
Ya, kita sekarang ni berada dekat
Tidak perlu lagi bergantung kepada unggun api
Let me
dan
watch this first.
bagi mendapatkan cahaya pada waktu malam. Kegelapan diterangi sinar cahaya dari tenaga solar bagi menangani masalah ketiadaan bekalan elektrik yang dihadapi lebih 600 penduduk orang asli di Pos Bidong, Cameron Highlands.
Ia hasil sumbangan Impak Malaysia, agensi di bawah Kementerian Belia dan Sukan. Ikuti siri kedua laporan Azraai Rakyat bersama wartawan Khairul Rizwan Azizan.
Malam kami memaparkan masalah ketiadaan bekalan elektrik di Pos Bidong, Cameron Highlands. Ia membataskan aktiviti penduduk orang asli, terutamanya pada waktu malam. Kanak-kanak juga menghadapi masalah memulai gaji pelajaran dan terpaksa bergantung kepada cahaya daripada pelita dan unggun api. Prihatin dengan nasib penduduk orang asli di kampung ini, pihak Malaysia tampil membantu pemasangan teknologi tenaga solar. Selain kampung Titong, kedua lagi kampung yang turut menerima manfaat daripada projek ini, Kampung Kemian dan Kampung Jernang. Secara keseluruhannya, projek berkenaan memberi manfaat kepada hampir 300 isi rumah. Setiap keluarga dibekalkan dengan sistem asas seperti panel solar, selain 4 biji lampu dan pengecas USB. Kami dapati di sini tak ada lagi bekalan tu. Kerana di Pos Titong ada 5 buah kampung. Okey. Lagi 2 kampung, saya tak pasti nama dia dah ada solar, dah ada tenaga solar. So di 3 lagi jenis buah kampung ni tak dapat because keadaan dia jauh ke dalam. Jalanan dia lebih kurang 2 jam ke 3 jam dengan off-road. So mereka memang tak dapat keperluan. Isu yang kita cuba ketengahkan atau cuba selesaikan di sini adalah berhubung dengan bekalan elektrik ataupun pencahayaan. Yang mana penduduk kampung di sini menghadapi masalah bagi pencahayaan waktu malam yang membantu mereka dari segi memasak, pelajaran dan juga dari segi melakukan aktiviti harian di rumah. Malaysia menjalin kerjasama dengan transport solar untuk melatih penduduk kampung memasang sendiri sistem solar di kediaman mereka. Lama lah kami tinggi untuk bekalkan hospital ni. Hari ini teknologi bersama kami terbukakan 60 keluarga untuk menerima. So kami harap penduduk dapat menerima manfaat ini dan menjaga sistem tenaga solar ini serta menuailah hasil penggunaan tenaga tersebut laras dengan objektif tingkat Malaysia bagi pembangunan belia dan sosial dengan penyertaan pelbagai sukarelawan di bawah satu bumbung. Kerjasama turut dijalin dengan 20 pelajar kursus kejuruteraan elektrik daripada Politeknik Sultan Azlan Shah Berang Perak sebagai pendedahan kepada mereka sebelum melangkah ke dunia pekerjaan sebenar.
Dekat rumah orang sini kita orang memasang sambil mengajar orang. Pada masa waktu kita memasang, pada masa sama kita mengajar orang cara untuk memasang dan juga maintenance. Apabila kami dah tiada nanti, mungkin mereka akan membaiki sendiri.
Jadi, kehidupan penduduk orang asli lebih sempurna dengan adanya sumber elektrik dari tenaga solar.
Yang lama sebenarnya. Lama kita menggunakan yang macam geser, pos-pos kita dah betul-betul bertawana. Kalau itulah atau macam persiapan dia mungkin banyak tu, tapi sama dulu memang susah. Dah dapat lampu macam ni, okey lah. Saya bersyukur.
kawan dan kegembiraan dan kekecewaan bagi penduduk di sini sebab menanti sekian lama akhirnya pesara-pesara telah disalurkan ke kampung mereka. Dan biasa bagi merapikan kegembiraan ini antara yang sewa dihancurkan yang begitu penuh dengan masyarakat orang asli. Walaupun penduduk orang asli di kawasan ini tidak perlu lagi hidup dalam kegelapan, mereka masih lagi dibelenggu masalah lain, khususnya jalan berlecak serta masalah bekalan air yang terpaksa bergantung kepada sumber dari sungai. Harapan disahirkan agar peruntukan 15 juta ringgit yang pernah diumumkan sebelum ini oleh kerajaan terdahulu untuk projek pembangunan jalan dapat diteruskan. Isu yang utama bagi mereka ini adalah infrastruktur. Infrastruktur ini terdiri daripada jalan, air dan elektrik. Itu perkara yang amat kritikal bagi pandangan saya. Karena yang utama sekali kalau dapat dilalui baik oleh kerajaan ataupun mana-mana yang Indonesia yang belum laksanakan dulu perhubungan jalan. Ini perhubungan jalan itu elok, yang lain-lain itu menyusul kemudian. Yang pasti, penduduk yang tinggal di kawasan pedalaman, termasuk masyarakat orang asli, tidak harus tercicir dari arus pembangunan. Ini kerana tanpa kemudahan asas, ia turut menyumbang kepada masalah lain yang lebih serius, seperti penyakit serta masalah sosial yang lain. Berikan aduan anda serta nombor telefon untuk dihubungi ke aduan rakyat 3.0@3.com.my. Laporan Nurul Rizwan Azizan, aduan rakyat 3, Cameron Highlands Pahang. Kami prihatin.
So that story has been covered from the Bulletin TV3. So where about 20 students from electrical engineering departments, Politeknik Sultan Azlan Shah, has contributed their experience, their times, their efforts to go to the post hitam by using the off-roads. It's very challenging because they have to stay there. There is no coverage for handphones because nowadays handphone is a very compulsory, every student in every day must use. So that's a very good opportunity to the students learn from the project-based learning, and they can gain the knowledge and also the experience with the penduduk orang asli at the post hitam. This collaboration is between Suncrocs Malaysia and Politeknik Sultan Azlan Shah. So this project-based learning has always been done for every semester to make sure the students can gain knowledge and also at the same time, not only they develop their academic skills, but also their attitudes, their behavior, the communication skills, how to speak, to say, to talk with other peoples, other races and also religious, and respect the culture. Because we are not only give the students to learn something academic, but also a lesson of life. How will they going to survive after they have studied in Politeknik Sultan Azlan Shah for 3 years and gain a diploma. So other than they learn in the power system protection and all kinds of subjects in the Polytechnic, they can share the knowledge to the society. So the reason why we need the solar energy, one of the most important thing is to give the technology to the other peoples that at the rural area. And the students also teach the people how to do the preventive maintenance, how to install the wiring installations, and also how to install the photovoltaics of the panel solar at their own house. Number 2, why do we need the solar energy? Because if we are using other methods to generate electricity, one of the things that release carbon dioxide and other greenhouse gases. So burning fossil fuels such as coal release carbon dioxide. These gases traps more of the sun heats in our atmosphere, causing the climate change. So what is the climate change consequences? I'll show you 3 here. Rising sea levels, what will happen if the sea levels is rising? Okay, you can see the second picture is the frequent flooding. If the area is low from the sea levels, it's possibility floods can happen there, especially where is the lowest in Malaysia. Okay. So last week I watched news. They said Kelang is possibility will having floods because of the low below the sea levels. So climate change consequence also can make the severe storms. So it will bring us disasters. Number 3, why do we need solar energy? Because of lack of natural resources. First, I want to show about what happened here in Malaysia or also in Indonesia, but then I think better I choose another country, right? Not Southeast Asia. So Haiti is and the Dominican Republic, as you can see at this picture, Haiti using the forest to provide wood for heat, but Dominican Republic did not. So this what happened when we view from the satellite. It's totally different. What will happen if you have deforestation? Okay, so potential dangers of deforestation such as erosions and also mudslide. So here in Malaysia, if you see the mudslides, it's happened in Pahang mostly because of the deforestation. Okay, the sun gives 100% radiance, but what Earth's surface in Earth receive? So solar energy is measured as power per unit area, watt per meter square. So 100% incoming solar energy, but these are the 6% reflected by atmospheres, 20% reflected by the clouds, 4% reflected by the Earth's surface, 16% absorbed by the atmospheres, 3% absorbed by the clouds, and only 51% reach the Earth's surface. From the 100%, it's only 51%. Okay. How many radians? The value. So as I do some research, it's about 19.3 billions, but only 51% reach the surface. So it only needs 8.5 minutes from the sun to reach the Earth to deliver the radiance. 8.5 minutes. Alright, so since Indonesian and Malaysians almost have a similar latitude on latitude, as you can see, this is the amount of solar energy changed with the locations. So different locations, you can see different radians. Along with the latitude here, you can see the red color. So it shows it received more than 270 kelvins in the temperature. So this is the latitude and latitude. So here is the Malaysian and the Southeast Asia, including the Indonesia. So we are in the, Malaysians are in the Khatulistiwa. Alright. So here is the amount of solar energy changed with time. Just now we see the amount of solar energy changed with the locations because each places in the world, the latitude and longitude is different. So different places, different radians that they see according to their geographic locations. This is the amount of solar energy changed with the times. I will explain it later. And how much solar can we get? So this is the example from the US laboratory. When we want to know how much solar energy, we must know how to set up the flat plate solar module. So the solar module should be oriented south at an angle from the horizontal equal to the latitude of solar collections. So for example here, the latitude of the boulder from the Colorado is 40.1 degrees. So the solar water heater is 41 degree from the ground facing the south. because we want to receive the maximum radiant from the sun. So okay, so you can use a lot of application nowadays. Okay, maybe you can take out your handphones now, or maybe from people audience from the outside also can use another Windows tab or Windows. You can type www.esrl.noaa.gov or Earth System Research Laboratory. Okay, as you enter the link, or if you type the gml.noaa.gov, you can see the Global Monitoring Laboratory. Okay, this is the actual. So it will show you the world maps, world cities. Okay, let's say now is 13 October 2022. Okay, I'm using the current time. So the time zone is you drag the red point. Okay, we jump from US goes to here. Okay, so since we are located in Perak, okay, drag the red location. Hold on, please. Okay, up. Okay, oops. Here is Politeknik Sultan Azlan Shah. Oops. Okay, I pinned to the electrical engineering department. Okay. This, oh, you cannot see. Okay, so this is a political engineering department, Politeknik Sultan Azlan Shah. Okay, so the latitude is 3.7678492. The longitude is 101.450037. The time zone is Asia, Kuala Lumpur. UTC offset is plus positive 8 hours. So this is the present times, current time. So if you want to, okay, if you want to know where is the sunrise, because when we want to install the solar panel, we must know where is the sunrise, because we want to gain as much as possible. So we can click for the show sunrise. So you can see the sunrise here. Okay, you can see the sunrise. And if you want to see where is the sunset, just click and then you know. So after this, my friends, we tell about the wiring, about the solar street lights installation in electrical engineering department. I'll just show you in general where to locate the sunrise and where to see the sunset and what is the solar declination. So here in Politeknik Sultan Azlan Shah, our geographic location is very good because we can receive a lot of sun rays. And also at the same time, it's always happen rainy every day, almost every day. And when it's rainy, actually, it's good for the solar panel because of free preventive maintenance. Clean the solar panel without any dust. So dust is an enemy for the solar panel, especially for photovoltaic cells. So the solar declination here is negative 7.72. 7.72. So from this laboratory, you can find the solar radiance along the year, because you also can calculate manually, but I won't show you how to calculate manually. It took the Greek alphabet as delta. So it takes time. But as you can see here, so the latitude for the North Pole that we put the solar panels is 3.7 degree. Okay, this is the Politeknik Sultan Azlan Shah. This is the declinations, the way to put the solar panel at the rooftop or wherever places you want to do. Okay, just now I show you about the solar declination from the solar declination negative 7.72. Okay. So solar declination angle is a concept of astronomy, but its understanding is also helpful in solar energy and photovoltaic PV system. So what is the solar declination angle? Angle is a angle. The solar declination angle is the between the rays of the sun and the equator. What is the equator? Equator is the dividing the earth from the north and southern hemisphere. So equator of the earth, it is usually denoted by the delta. So the solar declination angle is very useful in calculating the sun elevation and the azimuth angle. The solar declination angle is the angle that what makes days and night. Okay, what makes day and night. So you can see it also revolves around our sun and has its own orbit. As we might think, the Earth's axis of rotation is not perpendicular to the direction of the orbit. Instead, it has a little of around 23.44 degrees, 23.4 degrees axis of the rotation. It's not 0 degree, okay? It's still around 23.4. Because of this tilt, the equator of the Earth and rays of the sun always make some angle between them. It is what we call the solar declination angle, because when we want to put the solar panel, it is between that range. Other terms used for it are the sun declination angle. If you search within the books, journals, or research paper, there is a lot of terms like declination angle, sun declinations, and also solar declination. Actually, it's a same things. So the solar declination angle changes time to time. Since the orbit is moving, so it will change time to time. It's not at the same value. It's different because it's moving. It's not a constant number. It will be different every single day. However, the angle restricts itself between 23.4 and negative 23.4 degrees. It oscillates between these two numbers and it will never cross. The orbit will never cross between 23 to negative 23. Thus, we can conclude the maximum value of the solar declination angle is 23.44 and the minimum is negative 23.4. So the declination angle becomes 0 twice a year. Okay. So when it becomes 0, it happens on March 20 and September 22nd. On this day, the Earth's axis of rotation becomes perpendicular of the rays of the sun. So what is the effect of the declination angle to the photovoltaic solar? To make things simple, we will assume you live in the other countries from the northern hemisphere, for example. So estimating the declination angle is necessary to determine the solar elevation, because the solar elevation increase with the declination angle and it is highest in the month of summer. In other words, the sun moves over our heads in summer. It is the reason why in summer we tilt our solar panel at the lowest angles. That's the reason why here in electrical engineering departments, Politeknik of Sultan Azlan Shah, we tilt the angle is 3.7 degrees. Because why? Why? It is the highest. When you are at the US, summer is the highest to get the sun ray. Okay, so that's the reason in the summer, the solar panel will change to the lower angle. But we are blessed to the God here in Malaysia and also Indonesia, we are in the lowest latitude. So we don't need to highest the angle. I already sleep with the angle and angel. My bad. I do apologize. Sorry. So 3.7. You can laugh. Laughing is a good therapy, okay? Don't stress too much. So that's the reason why we put here in Politeknik Sultan Azlan Shah 3.7 for the latitude. Okay, because of the solar declination angle, and we have C at the global laboratory. Okay, that's the reason how we put the solar panel. But yet, how does the solar power or photovoltaic, because project-based learning that we do the installation here, we are using the photovoltaic panels. Okay, you must know what is the, how does solar power generation works. These diagrams that shows the sun so happy give the radiance to the earth, 51% absorbed. So the photon lights to the solar radiations travel 8.5 minutes with the 93 billions of the radiant. So solar energy works by capturing the sun's energy and turning it into electricity. Our sun is actually a nuclear reactor from the God gift to the humans. It releases tiny packets of energy called photon. So the photons travel 93 million miles, not the radians, okay? 93 million miles from the sun to Earth in about 8.5 minutes. Okay, when the photon hits, okay, when the photon hits a solar cell, the electron loose from their atoms. You can see we have the negative electrons and also positive hole, substrate base. We have the p-type silicon, depletion layer, n-type silicon. We have the strips, metallic strips that can go the electron to flow and can have a 0.58 voltage for direct current. So when photon hit the solar cell, they knock electron loose from their atoms. If conductors are attached to the positive and negative side of a cell, it forms an electrical circuit. When electrons flow through such a circuit, they generate the electricity. So that is a very basic, I hope I use the simple ways to explain how does solar power generation works. Don't ask me why this called n-type silicons. I don't study why it called n-type silicons. We have to research more why it called n-type silicons and p-type silicons. But generally, I explain the PV receive the radiance, the photon hits a solar cell, then knock electron loose, and conductor attached to the positive and negative sides of a cell form an electrical circuit and they generate electricity. That's the simple explanation. Okay. So that is only for one cell. What happens if the cell So this is a panel, a combination of the solar cells. We design it. So as you can see, solar panel converts the sun energy, direct current electricity, which is sent to an inverter. So this is what we call active solar. Okay, active solar, some other books or research, they are using direct sunlight. So you can either direct sunlight or active solar. It means that the sunlight can change to the electricity. Solar panel convert the sun's energy into direct current electricity, which is sent to an inverter. Okay, now from the sunlight, actually it's not alternating current, it's a direct current. Okay, it's a DC current. So the inverter converts the DC into an AC electricity. Okay, so number two, an inverter converts electricity from DC to alternating current. So any electricity flow from the inverter to the breaker box, which is direct the current to any appliance in the building that using the electricity. Okay, now now this is a good benefit. Okay, like can be a technopreneur where if you don't use your power, you can sell it to your national or you any of the suppliers. Like here in Malaysia, you have TNB, so you can sell it to the TNB, like a hybrid system where you can get extra money because of we don't waste the energy, we don't use it, and we can sell it to the back to the TNB provide. Okay, so these are the types of solar thermal. Okay, you have parabolic throw system, have solar power tower system, have solar dish engine system, and also compact linear Fresnel reflector. Okay, only the types. So for the solar thermal, most of the solar thermal, they will have a furnace or the tower or a boiling of water because the thermal will heat and boil the furnace, and then from the heat, it will change to the electricity. That is the differences between the solar thermal and also the solar photovoltaic. Okay, active solar and passive solar. Because active solar, we are using the light from the sun. But if we have clouds, we don't receive the lights. Actually, we can still receive the heat from the sun. Okay, that's the difference directly from the sun and indirectly from the sun, whether we have a cloud or not. Okay, these are the operation of solar thermals. As I mentioned before, they are the heliostat. Solar radiations is concentrated and reflected. This is according to the ancient China, Yang Shui, the burning mirrors. So what is the function of the burning mirrors, Yang Shui? To concentrate the sun. Another things? As accessories. They wear it, right? So that is their era of the fashion. Nowadays you can wear Alain Delon, Coach, Prada, the devil not wear. But at ancient China 3,000 years ago, they are using the Yang Shui burning mirrors as a belt for a man. So others then using it to concentrate the rays to set up the fire. But the same goes to the heliostat. Solar radiation is concentrated and reflected from the heliostat up to the receiver. Okay. The receiver, water is heated in the receiver to create very hot, highly pressured, supercritical steam. That means it's very extremely high temperature. Okay. So a pump pressurized and pump waters into the receiver. So when the water is very in a high temperature, it's very super duper heat, the steam flows to the turbine. So now the turbine is rotate because of the heat that they receive from the receiver. So inside the turbine, the steam expand and spin the turbine. So generator is connected to the spinning turbine and creates electricity to feed the grid. Okay, we are using the national grid here in Malaysia. Then after that, the cold water go to the steam condense and converts the steam back into water, and the process begins again. So solar thermal is okay if the very cloudy day because they only receive the heat from the sun. So anyone can tell me, in the country have solar? Do we have a farm of solar? Where? Melaka. Sepang. Don't mention it. You can Google it. You have your smartphone. Okay. The nearest to the Politeknik Sultan Azlan Shah, and also we have a good collaboration with the Guiding Channel. We have a farm of solar at Bido. Okay, at Bido. So here is Politeknik Sultan Azlan Shah. Okay, then we go to Gunung Bersaut. Okay. Here is Bido. Somewhere around here. Okay, somewhere around here. So, why the farm located at Bido? Can you see the latitude? It's the lowest latitude, right? 4.1 degrees. So, means that we receive the maximum radiance from the sun. Okay? We don't, if you were at the US, every summer, winter, you have to change your solar panel according to the seasons, according to the location, and according to the time. But here in Bido, since we are in a Khatulistiwa, we don't have to change. Okay, we can stay the solar panels at that position for the whole year. Okay, and at the current time, the solar declination also negative 7.72. Okay, where's the Azimah? Okay. You can see. So, Gading Kencana, Bido, the power that can given to the nearest area is 30 megawatt. But where is the largest solar power plant in the world? Okay, I give you about 5 minutes. Maybe other audience also can search, can find, and do tell at the chat in the WebEx. Where is the largest solar power plant in the world? Okay, where? China. India. India. Okay. If you say in India, from my research, in 2021, Badla Solar Park is the largest power plant in the world, which was completed in the year 2020. So in the year 2021, it's say that this is the largest solar power plant. But yes, in this year, Badla Solar Power Plant is not the largest. However, the Badla Solar Park can give you 2.25 gigawatt solar photovoltaic power plant and the largest farm in the world, encompassing nearly 1,400,000 acres of land. Okay, it's very big. Here you see in my slide, Gading Kencana only give you 30 megawatt. Okay. Alright. Here is Danau Tauban, Kelantan. The solar panels, where? In the water? On the water? Surface of water floating? Yeah, floating. If you do some research, the largest floating solar farm is located in Singapore. Okay, but in Malaysia, we have also the floating solar panel farm at Danau Tauban, Kelantan, and it will supply 140,000 megawatt, okay, to the area. Okay, types of solar photovoltaic cells, we have 4: monocrystalline silicon solar panel, polycrystalline or multicrystalline solar panels, amorphous thin film, and also hybrid silicon solar panels. So the most efficiency is monocrystalline, 15%, and the rest, the lowest is hybrid, so 4%. For the mono, the spaces is less, and for others is moderate, but hybrid silicon solar panel is using the large panel. Spaces doesn't mean about the size of the panel. I mean the space when you want to do the installations, okay? And the cost, of course, expensive, and the cheapest is the hybrid silicon. This is comparison by I do some research. So mono photovoltaic solar panels are silicon based of a variation of, there are several different types of solar. The main difference in solar panels is the purity of alignment of the silicon. The more perfect the alignment of molecules of silicon, the better is at converting sunlight into electricity. So I repeat, the main differences in solar panels is the purity or alignment of the silicon. The more perfect the alignment of molecules of silicon, the better it is at converting sunlight into electricity. Obviously, the more efficient panels are the more expensive. But this should not be your primary reason for choosing any type over another. Because you design, you know what kind of load, what kind of area, where the place you want to put it, as an engineer or as a designer for the solar installations. The most effective of the solar photovoltaic cells with 15% efficiency is monocrystalline. Therefore, the more expensive option, they require less space than other cells simply because they produce more energy and can less space than times more power than thin film solar panel. They also last longer than other panels and perform better at low light. Okay, why it's very expensive? Because the most effective of the solar, they are also longer than other panels and perform better at low light. Why it's very expensive and why some people choose monocrystalline silicon solar panel? Because they can receive at the low lights. Even though cloudy, they also still can receive the lights. So the main advantage is the cost. The only main advantage for the monocrystalline is the cost. So for the polycrystalline or multicrystalline solar panel, the efficiency is 30%. They are made from a number of smaller silicon crystals that are melted together and then recrystallized. The process to create them is simple and less wasteful than the mono. However, suffer at the high heat, it can reduce their lifespan. So the lifespan of the solar panel reduced 0.5% each year. But do not worry, by the time you 70, the solar panel still can perform and can generate electricity to your house. So it's a very good and vast investment. All right, I already tell everything about the solar energy, the beginning. Why I say the beginning? Because I want to tell at the early stage in terms of benefits to the human, they're using the solar for cooking, for weapon, and also to do some experiment melting materials because they are using their brains and thinking, do out of box. Okay, but do the evolutions of the technologies. For many, everyone does the research and we starting to do some investments and experiments from the scientists to the chemistries and so on. So we can see the developments of the solar industry here in the world. So do you have any questions to ask? If you ask me what is the benefits of solar energy, it reduces carbon dioxide, then there is no pollutions, and I think we can save the earth because no mudslides, no deforestation, and the lifespan of the earth can be very long. So our children can see how this earth is very beautiful, and we can travel, I think, go for each country and see the development of the solar. So thank you for today. I hope you can learn something. I hope my explanations is very simple, and I really hope that the knowledge that I share will give you some impact on your life. And I personally want you to be a solar cooker to gain the experience. Not we go back to the previous ancient history, no, but you must know how the solar cooker functions. All right. So thank you for today, everyone.
Okay, thank you very much for an interesting talk from Mrs. Hasnina Haji Abdul Rahman. So it's 11 a.m. So we have a short break, okay, around 50 minutes, and we will start at 11:15. Okay, thank you. Betul. Betul. Berapa? Berapa minit? 11 suku masuk. Corina dah masuk slide dah. Slide ke mana?
Boleh cabut, tak ada orang nak guna dah. Haji ni guna. Oh, mesti. Haji play nak foto itu.
كيف داعمها؟ جبت 4 5 شباب لحتى حسنا رفعناها، لانه صارت دوره.
Okay. Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all our honorable guests, speakers and students from Politeknik Sultan Azlan Shah, Malaysia and Politeknik Negeri Bandung, Indonesia. We will continue the next session on circuit design of solar system by Mrs. Norhasnina Mokhtar and Mr. Fauzi Ghani from Electrical Engineering Department of Politeknik Sultan Azlan Shah. Without any welcome Mrs. Norhasnina Mokhtar and Mr. Fauzi Ghani. Tak boleh share content. Kak Laila tak jadikan saya host.
Leave meeting. Kak Nina. Nina dah. Cuba kalau kalau saya nak start tak ada masalah. Sebab saya juga saya share je. Tadi share tak ada kok. Oh, dia tu kok ya. Tak. Set.
Yes. Diorang jadi host. Tak, teknikal tengah jadi host. Ni. Orang tak dengar. Sekarang teknikal jadi host. Oh. Sebab dia biasa tak boleh show sebab sentimen saya tak jadi
Bismillahirrahmanirrahim. Assalamualaikum and good morning everyone. Welcome to my sharing sessions. So let me introduce myself. My name is Norhasnina binti Mokhtar. I'm one of lecturer in Electrical Engineering Department in Politeknik Sultan Azlan Shah, Perak, Malaysia. So as you can see on the screen, our topic today is about circuit designs of solar system. During my session, I will focus on this topic. First, typical components in solar system. Second, solar components function. And third, solar system wiring connection. Solar energy system consists of different components that should be selected according to your system type, site location and applications. The typical components for solar system are: first, solar panel; second, solar charger controller; third, battery; fourth, inverter; and fifth, electrical load. Now, let's start with first component, which is solar panel. Solar panel generates electricity when exposed to sunlight. The electricity generated by the solar system can either be converted to usable power or it can be stored in a battery. Voltage and current are variable based on brightness of sun. This referring to photovoltaic solar type. Solar panels have two terminals, which is one positive and one negative. Solar panel can connect in series and parallel configuration to produce more output voltage or to produce more current. Solar panel are wired in series when you connect the positive terminal of one panel to negative terminal of another. When solar panel are wired in series, the voltage of the panel adds together but the currents remain the same. Based on figure shown of series connection, in this method, all the solar panels are of the same type and power rating. The total voltage output becomes the sum of the voltage output of each panel. Using the same 3, 6 volt and 3 ampere, we can see that when the solar panels are connected together in series, the array will produce an output voltage of 18 volt at 3 ampere. When solar panels are wired in parallel, the positive terminal from one panel is connected to the positive terminal of another panel and the negative terminals of the two panels are connected together. Wiring solar panels in parallel causes the current to increase, but the voltage remains the same. Based on figure shown of parallel connection, in this method, all the solar panels are the same type and power rating. Using the same 3, 6 volt and 3 ampere current, the total outputs of the panels when connected together in parallel, the output voltage still remain at the same value of 6 volt, but the total current has now increased to 9 ampere. Second components are solar charger controller. Basically, solar charger controller connected between the solar panels and battery. Solar charger controller regulating and controlling the output from the solar panel. Solar charger controller will prevent batteries from being damaged by overcharging and over-discharging. Therefore, it enhances the life of the battery bank. Solar charger controller also indicates the charging status of batteries like battery undercharge, overcharge or deep discharge through LEDs indications. The third components are battery. Battery are used for storage and backup operations when the direct power from solar panel are not available. The battery should be large enough to store sufficient energy to operate the appliances at night and cloudy days. Solar batteries typically contain two materials which react inside the battery in order to both store and discharge electricity. First, lead acid is an older and cheaper type but require regular maintenance and doesn't last as long. Second, lithium ion, which is the most popular type of solar batteries currently because can accept a faster rate of current and charging quicker. The fourth components are inverter. The functions of inverter is to change the direct current electricity captured by the solar panel into alternating current. Alternating current is the standard flow of electricity required to power your home appliances and connect to the national grid. Inverter located after a solar charger controller and battery bank. The sizes of inverter unit may vary depending on your usage and the equipment or appliances that you have. The last one are electrical load. Electrical load is any device that consumes electrical energy and transform it into another form. This device will consume electrical energy in the form of a current and transform it into another form. The electrical energy is often transformed into forms such as light, motions, or electric heat. Electrical load operate using DC or AC voltage, and the selections of electrical loads depends on your application. Okay, now since you are familiar with solar system component, so let's start with solar system wiring connections. In the simple of solar panel wiring system, I will show you how to connect a solar panel to the solar charger controller, battery, inverter, DC and AC load. As we have only single unit of solar panel, so we don't need to connect the solar panel in series or parallel. Because of solar panel produce direct current, supposedly DC load can power up by solar panel directly. But that's method not recommended because the solar panel generate variable current and variable voltage. To overcome these issues, which is to get the steady voltage to DC load, solar charger controller and battery are added to the system. Because of the sun is not always available, but the load must to be fed at any time of the day, so the power from solar should be stored in a battery bank. Then, the solar charger controller functions to protect the battery from overcharging, besides it regulating and controlling the output from solar panel. To add AC load in the solar system, inverter will be added between solar charger controller and battery. Inverter will change direct current to alternating current to support AC load. So that's all for my part. I will pass these sessions to my friends Encik Fauzi bin Ghani to continue our sharing. Thank you.
Okey, bismillahirrahmanirrahim. Alhamdulillahirabbil wassalatu wassalamu ala rasulil mursalin wa ala alihi wa sahbihi ajma'in. Allahumma salli ala sayyidina Muhammad wa ala ali sayyidina Muhammad. Rabbi yassir wa la tu'assir. Rabbi yassir wa la tu'assir. Rabbi yassir wa la tu'assir. Amma ba'd. Okay, good morning to all of you. And firstly, thank you to Puan Hasnina. And then also thank you to my beloved student from Malaysia, Politeknik Sultan Azlan Shah. Then also to student from Politeknik Negeri Bandung. Okay, sorry. So, firstly, I would like to ask maybe permission like to speak in orang kata 3 bahasa. Okay, bahasa Inggeris, bahasa Malaysia and bahasa Indonesia. Okay, so hopefully dapat saya nak tanyakan di Indonesia sekarang jam berapa ya? Ada yang boleh respon di sana? Okay, di Malaysia sekarang adalah jam 11.56, menghampiri jam 12 tengah hari. Okay. Ada respon daripada saya mengharapkan ada respon daripada saya check dia. Okay, thank you. Okay, tak apa. Kalau sebenarnya saya pun agak kekok dengan ni. Okay, never mind. So we proceed maybe we can proceed our sharing knowledge today. So today, maybe I will proceed about solar system design. Just now telah dibentang oleh Puan Hasnina. Okay, so 10:54. Okay, untuk makluman pelajar-pelajar di Politeknik Negeri Bandung. Okay, sebenarnya saya pernah di Bekasi Timur pada tahun 2017 di PT JST. Saya menjalani latihan engineer training di sana selama 6 bulan. So pernah merasa, orang kata pernah makan nasi uduk dari sana lah. Nasi uduk best di sana. Okay, Alhamdulillah. So we proceed. Maybe saya akan ambil masa lebih kurang tak lebih 30 minit lah. So solar system design for purposely for LED lighting lah. So we focus on LED lighting. So okay, sepatutnya saya boleh terus bentang kan? Okay. Okay. Firstly, why we go for solar? Why we go for solar? Persoalan ini kita harus jawab dululah. Kenapa kita memilih solar? Okay, kenapa pilih solar? Sometimes ada orang kata prediction ataupun pendapat mengatakan solar mungkin dia dari segi initial cost dia mahal. Okay, highly cost. Okay, and sometimes ada pendapat mengatakan kalau kita berjauhan daripada sumber bekal elektrik, so better go for solar. Okay, so that's why I put here three orang kata kriteria lah. So kenapa, why we go for solar? So firstly maybe dari segi environment reason. Okay, we go for free carbon, and then second we go is energy saving, untuk menjimatkan kos. So sebenarnya ada kriteria lain lah kenapa kita pakai solar. Dari segi energy saving ni mungkin dari segi penggunaan elektrik yang banyak, mungkin kalau kita for long term we better go for solar energy. And then dari segi cost saving pula, mungkin dari segi cost bil elektrik ataupun cost dari segi kita nak pemasangan sistem solar tu, kita boleh consider juga. Okay, dan kita perlu calculate berapakah initial cost and for short term and for long term. Okay, so next is okay kan? Okay, maafkan. So solar sun hour is the unit measurement for determining available sun in location. So yang lebih mudah, kalau bahasa Indonesia, maafkan saya, orang Malaysia, lebih gampang dipahami dengan orang kata solar panel terdedah kepada cahaya matahari. So bukan bermaksud daripada katakan kita masuk waktu siang, okay, orang kata waktu siang daripada pagi sampai petang tu, orang kata waktu yang average untuk kita touch solar panel. So kalau berdasarkan, kalau lihat di sebelah, kita ada orang kata peak hour lah, yang kalau ikut merujuk graf ni, waktu yang kalau bermula pada jam 9 sampai jam 4, okey. Tapi kalau ikutkan berdasarkan lokaliti lah, berdasarkan tempat, kalau di tempat kita ni di Perak, di Malaysia ni lebih kurang 4 jam saja yang dikira. So walaupun dia charging, solar panel tu charging daripada pagi sampai ke petang, so boleh kira peak hour-nya selama dalam 4 ataupun 3.5 jam saja. So maksa yang orang kata peak hour untuk charging itulah. Faham tak? Boleh ya? Diharap di sana, di Indonesia sana, pelajar-pelajar orang kata bisa faham. Okay? Bisa bahasa Indonesia ya. Okay. So, understanding sun hour allows us to understand more about how the solar system is sizing is performed. So, bila kita faham berkenaan dengan solar waktu, solar sun hour ni, kita mungkin dapat decide berapa saiz solar panel yang kita akan pakai, dari segi ukuran dia berapa jam untuk dapatkan charge solar panel dan sebagainya lah. So, then different setup, different ways. So that different setup use different ways of calculating the available of the sun for specific location. So kalau kita nak pergi pasang pemasangan solar, kita at least kita ada informasi, maklumat dulu pada satu tempat. Katakan mungkin kita pergi luar negara ke, di Indonesia, di Thailand, mungkin dia ada different punya apa panggil solar sun hour lah. Okay, ada kajian yang dibuat. Ini pun data yang saya ambil ni pun daripada sebenarnya daripada Google, daripada kajian individu tertentu lah. Okay. Alright. Sebentar ya. Kaku pula. Mic dia kaku. Okay. Okay. Seterusnya, next we proceed with solar terminology. Yang ni saya lebih fokus pada, kita boleh katakan umum lah. Tapi saya di sini sebab kita fokus purposely for LED lighting. Tapi terminologi ni terpakai untuk semua lah. Okay. The firstly, kita kena tahu apa itu watt. Okay. Watt. Okay. Terminologi watt ni is unit for measuring power. Actually, sometimes for PV. Okay, PV short untuk photovoltaik lah, kita panggil PV. Okay, solar panel bahasa Melayu. Okay, dan sampai dalam ukuran bagi load, bagi lampu, bagi beban-beban yang lain pun kita akan kira dalam unit watt. Okay, dan seterusnya next is ampere. Dah tentu ini adalah unit bagi current. Okay, unit measurement for determine the amount of electrical charge. And then ampere hour is adalah ini unit bagi biasanya dia yang terpapar pada bateri. Okay, bateri solar. Apabila kita beli ada unit ampere hour. Nanti saya akan kongsikan. Okay, kemudian lumens is ukuran bagi cahaya bagi bulb ataupun lampu lah. And then terminologi yang berikutnya adalah autonomi. So autonomi ni biasa kalau kita masuk dalam bidang solar ni memang kena tahu. Autonomi ni lebih refer kepada bateri tu. Bateri tu kita pakai berapa persen. Okay. Number of day, maksud saya, number of day for battery storage has 4 times of bad weather. Contohnya, saya bagi contoh kat sini lah. Kita beli bateri 100 ampere per hour. Okay. Mungkin 12 volt lah. Itu spek dia. Satu bateri solar biasanya kita kena tahu spek dia. 12 volt ke 24 volt DC je. And then di sebelah tu dia akan ada mention berapa ampere per hour. Okay. So kebiasaannya dia akan bagi kita bila kita calculate kita akan dapat tahu ampere per hour. Kita tahu kita tengok ampere per hour, dia akan bagi orang kata jangka masa bateri tu boleh bertahan. Okay. Tapi dari segi autonomi ni kita ambil perkiraan. Let's say kata kalau kita charge fully bateri tu, hari pertama kita charge, kemudian hari kedua kita tak boleh nak charging disebabkan oleh bad weather ataupun hari mendung. Sebenarnya hari mendung masih boleh charging lagi, solar panel boleh charging. Okay. Tapi let's say kata dia tak boleh charge full kan. So perkiraan autonomi ni dia ambil kira hari yang bateri tu tak boleh charge lah. Katakan kalau 2 hari berikutnya bateri tu tak boleh charging disebabkan oleh faktor cuaca dan sebagainya. So kita ambil kira bateri tu boleh tak bertahan selama 2 hari selepas yang tak boleh charging. Itu dipanggil autonomi lah. So dikira dalam bilangan hari. So dalam calculation nak solar tu kita kena kira agak-agak berapa hari autonomi yang bateri itu boleh bertahan. Disebabkan apa? Disebabkan bateri tak boleh charging lah, cuaca tak baik dan sebagainya, tak boleh full charging. Faham tak? Okey. Kalau harap boleh faham lah, saya dah cerita dalam bahasa yang mudah, insyaAllah. Okay. So, and then that of the charge, okay, DOD atau dipanggil DOD, the amount of power pull from battery. Okay. So, sometimes kita perlu masuk dalam calculation juga DOD. DOD ni maksudnya, kenapa perlu DOD ni biasanya dari segi penggunaan. Katakan kita charging full, bateri tu is 100%. So, kita gunakan 25% je bateri. So, DOD dia is 25% lah. Okay. Tapi, untuk memanjangkan jangka hayat bateri tu, so kita tak boleh guna bateri tu sebanyak 100% ataupun DOD-nya tak boleh kita guna 100%. Jadi mungkin kita boleh guna sebanyak 70%, 60%, and then kita charging balik bateri tu. Okay, supaya apa? Supaya bateri tu boleh bertahan lama. Okay, sama contoh kalau kita pakai handphone kan. Semua pakai handphone kan. So dari segi penggunaan baterinya, kebiasaannya kita akan guna sampai 20% atau 10% yang tinggal. So, kita akan recharge balik kan. So, konsep dia sama. Boleh faham Okay. So, kalau boleh faham, so better we proceed for next. Okay, where is solar lighting word? Maksudnya di sini kat mana kita boleh pasang lampu solar. Okay. Dekat mana kita boleh pasang lampu solar. So, di sini saya bagi 3 example sahaja. Okay. Sebenarnya boleh jadi mana untuk for decoration, untuk apa lagi. Tepi jalan, di bus stop dan sebagainya. So, kat sini saya bagi umum. Overall, orang kata umum lah. Untuk kita buat landscaping, untuk kita pasang di pathway, ataupun di car park dan sebagainya. So, kalau kita lihat di sini, di Politeknik sini kita pasang di lorong ataupun koridor pejalan kaki, kan? So salah satu application lah yang kita buat. Okay, alright. Ini mudah saja, ini sekadar contoh saja. Alright. So ini gambaran keseluruhan sistem solar yang kita ni lah. Okay, for DC output ataupun off-grid DC lighting. So sebenarnya dalam sistem ni kita tak pakai inverter. So inverter ni hanya untuk AC load saja. AC load. So kemudian apa yang kita buat di Politeknik di Sultan Azlan Shah di Malaysia ini, kita hanya buat DC light saja. Okay, mungkin sahabat kita ataupun next speaker will show akan buat live lah pada tempat pemasangan nanti. Okay. So di sini ada solar, kemudian tersambung terus ke solar charger controller. Solar charger controller akan ada yang DC load, akan terus pergi DC load. Kemudian akan tersambung ke bateri, dan bateri ini kalau kita ada AC load, kita akan sambung pada inverter, dan inverter akan pergi pada AC load. Okay. So far so good. Okay, alhamdulillah. Okay guys, saya dah terbiasa dengan guys juga. Alright, seterusnya kita lihat. Okay, ini pun sama, cuma nak menunjukkan contoh-contoh yang lain. Okay, penggunaan dari segi main battery, dari segi kalau ikutkan kita tengok di sini size-nya 12 ataupun 24 VDC lah. So di pasaran sana ada pilihan lah untuk kita beli. Tapi dari segi pemasangan, installation, we have to match dari segi DC board. Okay, faham ya? And then dari segi output, AC-nya mungkin boleh kepada lampu AC, pada kipas, ataupun for charging USB dan sebagainya. Alright. So ini adalah kesinambungan bagi solar panel. Bagi solar panel tadi Puan Hasnina dah bincangkan sedikit. So saya proceed sikit lagi, tambah input sikit lagi sebagai perkongsian bersama. So solar panel, what shape, what size and type do solar panel come in? So di pasaran sana ada banyak jenis solar panel, ada yang jenis solar array yang fleksibel pun ada berdasarkan panjang dan lebar dia, ada berdasarkan dia punya size watt dia kan, dan biasanya dia ada di solar panel ni biasanya dia akan ada detail berapa voltan dia, dan juga apabila kita nak beli solar panel ni apa yang kita biasanya detail maklumat yang kita perlu, berapa watt, okey. Kemudian ada yang selalu kita lupa adalah efisiensi dia. Sebab apa, solar panel ni dari segi operasi dia ada loss dia. Dia ada loss dia. So we have to consider efisiensi sekali. So dari segi harga market, apa yang kita beli di sini 100 watt tu dalam 300 lebih juga lah. 300. Kalau kita nak convert, saya tak pasti. Sekarang dulu masa saya ke Indonesia sana, RM1 sama dengan RM2,500. Saya tak pasti sekarang berapa. Okay. RM1 masa tahun 2017 sama dengan RM2,500. Okay. Dulu masa saya pergi di Indonesia, saya jadi jutawan. Okay. So and then we proceed this. What size solar panel do I need and how many? So dari segi size dan bilangan solar panel ni kita perlu kepada perkiraan lah, calculation. We have to do initial calculation lah. Dari segi calculation nanti slide yang berikutnya saya akan cerita sedikit. What type of solar panel bergantung pada tempat yang kita nak pasang. Okay, mungkin yang perlu yang fleksibel, yang saiz kecil atau saiz besar. Okay, dari segi tempatnya kita perlu tentukan. Locating your solar panel very important. Okay, pasal locating, okay, firstly apa yang kita perlu tentukan, of course, orang kata tempat tersebut, okay, perlu kepada cahaya matahari yang direct lah. Okay, jangan ada mungkin orang kata shading ataupun pokok yang melindungi daripada cahaya. Okay, tak boleh ada pokok. So that's why sebelum kita pasang, firstly kita kena pergi site assessment dulu. Site assessment maksudnya kita pergi tengok tempat dulu lah. Tempat ni sesuai tak. Okay, saya nak kongsikan di sini. Sebelum kita buat pemasangan di Politeknik di sini, kita buat site assessment. Ada yang nak pasang first sekali tepi bangunan akademik tapi ada pokok. And then di belakang sana, pada tempat parking kereta, kita fikir dari segi faktor security, takut benda tu nanti diganggu ataupun hilang tiba-tiba. Sebab barang solar ni, terutamanya bateri, dia agak mahal. So kita fikir takut nanti faktor security, takut dicuri ke, jual ke dan sebagainya. Tapi benda tu, orang kata langkah awal lah. Okay. So to be positive, kita pilih tempat yang selamat, yang pelajar selalu untuk terus tempat yang pelajar selalu gunakan jalan tu dan pelajar boleh tengok apa itu solar. Okay. Alright, locate the panel where they will receive full sunlight between the hours 10 AM to 3 PM. So ini masa yang ni, kalau ikut kita punya kajian awal di Politeknik sini, jam 8 tu matahari dah ni lah, dah boleh direct sampai kepada solar panel yang tempat kita pasang tu. Okay, memang dia cantik menghadap matahari. Alright. So, sikit lagi. Okay, solar charger controller. So, solar charger controller ni is the main component lah. So, dalam ni ada sistem elektronik yang akan kawal keluar masuk arus pergi ke bateri, dan keluar daripada bateri pergi ke load. So dia akan limitkan, let's say kata kalau bateri dah penuh, solar charger controller ni akan stopkan daripada charging bateri tu. Okay, let's say kalau kata kemudian dia akan kita current tu boleh pergi kepada load. So ada berbagai sizing solar charger controller ni, ada yang 12, 24 dan 48 VDC. So macam mana kita nak pilih 24, 48 ni? Bergantung pada sistem pemasangan solar kita. Jadi kita kena mesh. Okay. Let's say kata sistem kita pakai 24. Solar panel kita ada 12. So kita kena dari segi penyambungan solar panel tu kena mesh, jadikan dia 24. So either kita nak sambung series or parallel. So kita kena tentukan. 12, kalau siri dengan 12 jadi berapa? 24 kan? Betul tak? So kalau selari dia akan dapat 12 saja. Tapi kita kena faham, we have to understand dari segi macam mana current dia pula. Adakah dia bertambah ataupun dia sama. So that's why kita kena tentukan. Okay, solar lighting controller allow you to control DC light while simultaneously charging a battery bank from solar to panel. Okay, next. Okay, ini adalah contoh sambungan bagi apa nama solar charging controller. So basically ini yang jenis PWM lah. PWM. Dan satu lagi kita ada jenis PMMTT apa tu? Saya lupa dah. Okay, sekejap lagi ada slide, next slide ada. So kita basically ada 6 penyambungan kat sini. Saya cerita ringkas lah. Nanti presenter akan cerita lebih. Dia orang akan buat demo. Okay, so daripada solar panel, 2 kabel masuk, 2 kabel keluar pergi pada bateri and 2 kabel lagi pergi kepada load. So ini yang dari segi USB port ni ada yang solar depend on brand, depend on jenis. Okay, ada yang tak ada, ada yang ada. Okay, kalau yang tak ada, kita nak buat macam mana? Kita beli aksesori yang USB lah, kita boleh sambung dekat load ni. Alright. Type of solar charging controller. Okay, tadi yang ni Puan Hasnina dah. So, lebih kurang. Cuma saya tambahkan sikit di sini. Comparison between PWM and MPPT. Okay. So, secara mudah untuk kita faham. Okay, PWM biasanya kita akan guna yang 200 watt below lah. Sesuai kita guna. Untuk, let's say, untuk 200 watt solar panel 200 watt yang ke atas, kita better pakai MPPT. Okay. Dia ada pro and con dia lah. Tapi tidak semestinya. Okay. Kalau nak ni, kita boleh cuba buat uji kaji. Okay. Cuma apa berdasarkan pengalaman saya dan apa yang saya tahu di sini, kalau untuk projek yang kecil-kecil, untuk pasang lampu tepi rumah ataupun koridor yang tempat kita pasang ni, kita dipakai yang jenis PWM saja. Pulse width modulation. Okay. Dia lebih ni lah. Kalau bateri dah ni dia boleh ikut. Let's say dia katakan kita beli solar panel 100 watt. Dia punya voltage output dia adalah 18 watt. So bila kita sambung kepada solar PWM ni, dia akan regulate voltage jadi 12. Faham tak? Dia akan regulate voltage jadi 12 dan dia akan charge bateri, masuk kepada bateri. Alright? Okay. Okay, next bateri. Okay, sama macam Hasnina tadi, cuma saya tambah sikit lah. Bateri yang kita pakai lead acid rechargeable battery. So apa yang perlu kita faham di sini, 12 watt 7 ampere per hour. So ini term yang perlu kita faham lah. What does it mean by 7 ampere per hour? Okay, 7 ampere per hour. Okay. Okay. Katakan kita ada satu lampu 5 watt. And then 5 watt bahagi dengan 12 dapat berapa? Okay. Katakan dapat 1 ampere kan untuk penggunaan lampu tu. Katakanlah, contoh. Lampu tadi kalau nak dapat 1 ampere 5 watt bahagi 12 lah. Tapi yang tu dah ni lah. Katakan 12 watt bahagi dengan 12 watt WATT power bahagi dengan 12. Ni dia akan dapat 1 ampere kan. Okey, so 1 ampere tu kita darab dengan jam penggunaan, katakan 1 jam je. So kita akan dapat 1 ampere per hour. Tapi secara logiknya kita akan gunakan 12 jam kan. Betul tak? 12 jam. Katakan jam 7 malam ataupun sampai pagi. So kalau kita darab 1 ampere darab 12, dia akan dapat 12 ampere per hour kan. Betul kan? Sebab kita darab dengan jam. Okey, so di sinilah term ampere per hour tu yang awak kena faham. Kita kena faham lah. Kalau tak faham term ni, susah kita nak buat calculation for solar. Okey. So bateri ni dia ada ni lah, ada yang 12, bukan 2, 12, 24, ini typo 24, 48. Okey, untuk sistem lampu kita. Tapi kalau lampu kita 12 volt punya rate, boleh tak kita pakai 24? Macam mana? Okey, sama-sama fikir. Alright, and then inverter ni especially for kita kalau kita nak pakai AC load. So basically, katakan saya ada 1000 watt. So macam mana apa ketentuan yang kita perlu ambil kira 1000 watt ni? Nah, ini adalah jumlah bagi keseluruhan load yang kita ada lah. Tapi sepatutnya kalau kita inverter kita 1000 watt, so jumlah watt bagi beban-beban dalam tempat kita nak pasang tu mestilah kurang daripada 1000. Faham tak? Let's say kita ada kipas yang jenis AC, maybe 10 watt. Okay, mungkin ada oven pula mungkin 200 watt. Okay, apa lagi, peti sejuk, aircon dan sebagainya. So total dia katakan 800 watt. Okay, adakah 800 watt tu sesuai kita pakai inverter yang ni? 800 kan bawah daripada 1000. So of course lah sesuai. Betul kan? So mesti ada ni, kita tak boleh lah pakai 800 ngam-ngam. Okay, tak sesuai dari segi mungkin ada short circuit dan sebagainya. So better over than 800. Okay, InsyaAllah kita sambung sikit lagi. Solar wire and cable. So ini sebenarnya adalah accessories for ni lah. So sebenarnya solar cable ni dia berbeza dengan katakan wiring untuk rumah. So dia ada sizing yang berbeza. Dari segi metal yang dalam dia pun dia agak kecil nak comparekan dengan kabel yang kita pakai untuk soket di rumah. Okay. Yang ni kena tahulah. And then ini yang ujung hitam ni dipanggil MC4 untuk kabel connector. Okay. And in case kalau kita tak ada aksesori ni, boleh tak kita sambung pakai biasa je? Boleh tak boleh? Boleh boleh. Tapi untuk proper kita pakai konektor ni lah. Cuma nak bagi tahu kalau kita pasang konektor dan sebagainya sebenarnya dia ada rintangan lah. Voltage dia ada rintangan pada penyambungan tu. Okey. So ini adalah kemuncak ataupun bagi pembentangan saya ini adalah poin yang penting. So design practice of off-grid solar PV system. So yang pertama apa, bila kita nak design, nak buat pemasangan solar, lampu solar dan sebagainya. So yang pertama kali kita kena determine dia punya load energy dulu. Okay. Dia sama dengan konsep dengan pendawaian biasa lah. So sekali kita kena determine berapa biji lampu kita nak pakai, load line berapa, and then kita calculate. Tapi untuk solar kita mungkin kena divide lah. Kita kena calculate DC, kalau kita nak pakai DC berapa total load untuk DC, berapa total load untuk AC. And then determine the size of solar array. Sebenarnya dia ada step lagi. Bila dah ada ni kena calculate dari segi berapa banyak masa. Dia ada step detail, nanti insyaAllah next presenter akan share with you all. And last kali determine the battery size. Determine the battery size. So depend pada jumlah beban, masa, faktor masa dan ada segi anatomi, okay, dari segi DOD bateri, semua kita kena calculate, ambil masuk dalam calculation kita. Okay, so that's why at the beginning of my presentation tadi saya bagi term and terminology yang awak kena faham dulu, yang you all kena faham. Sebab bila kita nak buat calculation, kita kena masuk sekali. Okay, battery size, ampere per hour, watt, current, DOD, anatomi, okay, dan lain-lain lagi lah. Alright. So advantage of solar ini sebenarnya banyak. So many advantage. Cuma saya sikit saja kat sini kongsikan. So they not run electricity and therefore not require stand electrical power. Solar light easily install. Tapi mahal dari segi costingnya, agak mahal lah. Sebab tapi nak comparekan dengan beberapa tahun lepas tu, sebab orang kata sekarang market dah rendah lah sikit lah. Sebab banyak dari segi pembekal. solar light provide a gentle limit LED operate more efficient of 12 or the BDC power than AC. Okay. Okay, itu sebut sedikit saja. And disadvantage banyaklah. Ataupun saya pun listkan tak berapa banyak kat sini. One of the disadvantage dia kata apa ni? The color of solar light can be too blue with some style of LED. Sebenarnya banyak jenis LED di market. Ada yang mungkin dari segi color putih, kuning, ada yang colourful dan sebagainya. Okay, some less unit can be flimsy and not last as long as commercial. Okay, dari segi jangka hayat lampu LED. Kalau kadang-kadang kita beli yang murah tu, dia punya jangka hayat dia tak berapa lama. Okay, and then there is no solar power at night. So there is a need for large battery. So bila consider tak ada cahaya pada malam ni, that's why kita kena consider dari segi bateri, autonomi bateri, DOD pada bateri tu. Tapi bateri ni kalau ikutkan pengalaman kita beli peralatan untuk buat projek ni, bateri yang paling mahal. Kita hanya pakai 33 ampere hour, tapi harga dia RM385. Kalau yang 100 ampere per hour, saya tanya kat market dalam 900 lebih. Menghampiri 1000 lah. Okay. So, kalau you all, pelajar-pelajar kita nak buat projek, mungkin kena menyimpan duit daripada awal semester lah, untuk beli 100 ampere battery. Kan? Betul kan? Okay. And depending on geography location, the size of solar panel, okay, dari segi solar panel pun bergantung pada tempat. Okay, bergantung pada tempat, bergantung pada saiz dan sebagainya. Dari segi maintenance-nya sebenarnya tak susah sangat. Cuma perlu cuci dari segi permukaan dia supaya dari segi efisiensi dia baik, pada tahap yang terbaik dan mempunyai charge yang baik lah. Dapat solar light yang baik. Okay, itu saja daripada saya. Mungkin ada persoalan, boleh ditanyakan di chat ataupun mungkin pelajar-pelajar di sini nak tanya. Ada soalan? Tak ada. Okey, mungkin pelajar-pelajar ataupun teman-teman di Indonesia sana ada persoalan? Saya tak dapat tengok chat. Oh, ada di sana. Terima kasih Tusas. Jika ada soalan boleh kemukakan di ruangan chat. Okay, thank you to all. So, kalau tak ada question, saya serahkan kepada Puan Pengerusi Majlis untuk teruskan program kita. Thank you.
Okay, thank you very much for valuable knowledge from both speaker, Mrs. Norhasnina Mokhtar and Mr. Fauzi Ghani. So now is 12:50 p.m. So we have a lunch break, okay, and start our program around 2 p.m. Okay, 2 p.m. Malaysia or around 1 p.m. Indonesia. Okay, thank you.